Here are 3 IGBTs from a Yaskawa inverter drive GPD506/P5. Now what happened is the low side IGBT for the W leg shorted. That's this right here. So we have C2 E1 to E2, and that's a short circuit right there. Now if we go C1 to C2 E1, we have good diode drop, 0.372 volt diode drop. Let's go ahead and check the other ones. Okay, that's C1 to C2 E1, that's good, 0.370. Here's the last one, C1 to C2 E1, we have 0.370. Now we'll check the other 2 low side IGBTs. Here's C2 E1 to E2, that's good, 0.370. And here's C2 E1 to E2, 0.370. So this one here, low side IGBT in this power module is bad. Now let's move these 2 out of the way. Here's our problem. Let's check to see if that short circuit energy shot back up through the gate. Here's E2, G2. And let's go to this one right here. Yeah, look at that. That's C2 E1 to G2, and it's shorted. Yep, short circuit right there. And here is the power board. Here's our gate firing channels right here. Now I've already gone through and tested all of the devices with my meter. I could not find anybody that was shorted nor open. But when I put this drive back together with all new IGBTs, the low side W leg did not fire. So when that short circuit energy shot back up into the circuit right here, it damaged something, even though I can't find anything bad. I got 2 other circuits here that I could compare to, and they seem to measure all the same. I tried to figure out how to power up this board so I could individually check those firing channels, but I can't figure out how this switcher starts up. So what I'm going to do is I'm going to remove the bus bar from the ground side of the IGBTs so that and then reinstall this board with the control board on top of it, and hopefully power it up and not come up with any alarms that would disable me from running that drive. And while it's running with the IGBTs disconnected, I'll be able to look into the circuitry with an oscilloscope and try and figure out who the bad part is. Now, if you look at this board, there's a lot of tiny surface mount items right there, and I kind of mapped out that firing channel. And let's move all this out of the way and I'll show you what I got mapped out. Can you hear the roof leaking back there? I got like 10 buckets back there. It's like a doggone cartoon here. Okay. There's my rant for the day. I spent the last half hour just trying to mop up over there. Let's get a little bit closer to the circuit right here, and you can see what we're up against. Now this is all surface mount, and we have an optocoupler right here, PC929, and then we have a totem pole configuration right here, and the output of the optocoupler fires into the totem pole, and the output of the totem pole circuit fires into the gate of the IGBT. Now this is the low side. There's 3 identical circuits to this for low side U, low side W, and low side V. This connector right here goes up to the control board, and the control board drives the input of the optocoupler's input LED. This is all surface mount. And these resistors and capacitors and diodes, transistors, they're all tiny. But I've looked at everything. I've put my meter on this IC compared to the other two low side firing circuits. No difference. The resistors, no resistors are open. No transistors are open. I've got 10 ohms between the bases of the NPN and PN transistor to pin 11. It's not open. This resistor right here, 100 ohm, it's not open. There's absolutely no reason that I can see that we don't have gate firing circuitry on that IGBT. Well, we've got power problems here with the storm over our head, and I'm not going to power this drive up today. I don't want it to. Do you see the lights flicker? I don't want to have that drive powered up and then lose power and then come right back up and cause some kind of problem with that drive. So we're going to put it back together as best we possibly can without the low side bus bar on the IGBTs. And then tomorrow, when we come out the other side of this storm, we'll go ahead and try to troubleshoot that gate firing circuit right there. Let's go over to the drive, and we'll put that firing board back in the control board. Right here is where the 3 IGBTs reside. And I've removed this board that couples the C2E1 connections of the IGBTs to U, V, and W, T1, T2, and T3. I've also removed the E1 bus bar that connects to this fuse down here. And the hope is that when I put this drive back together, minus those 2 parts, we'll be able to power up this drive and look at the gate firing signals. Here are the gate connections right here. Now, what might happen is that when we power up this drive, because we don't have these connections, we get an alarm. And then we won't be able to run the drive. Okay. Let's start to put everybody back together. Set that right there just for now while I move these other parts out of the way. Let's go ahead and hook these up while we got this out here. A little bit easier to hook up while we're not against that wall. Make sure we got everybody out. Put these up over here. Two. Okay, we got all not going to cinch anybody really tight because we're taking it back apart to put those the current sense board and the ground bus bar back in after we get done troubleshooting. 8, number 9. For the cooling fans. All right, we'll hook up the gate firing circuitry. Let's see what we got here. You're missing one. You're missing one. I think it's this one. Yes. 17. Had it buried underneath the power board. 18. It's nice what they do. The boards are very well numbered, and they have numbers on the connectors. So here's 21. Goes right here. 20 is right next to it. There's 19. Now our W low side IGBT gate emitter go to pins 1 and 2 on the 18CN connector. I'm not sure, but on that current sense board plugs in right here. And I'm wondering, I'm going to try it without that hooked up, but if we get like a overcurrent or undercurrent alarm, I'm going to hook that connector up right here off that current sense board. That goes out to T1, T2, and T3 from the IGBTs. These screws right here hold the CPU board. I like to put screws back where they come out. Makes it a little bit easier when you go to put things back together. You don't have to try and figure out what screw went where. Hear that rain on the roof? Whew. Oh, I'd hate to be out there in that weather. I imagine if I was driving right now, I wouldn't be able to see through the windshield, even with the wiper blades running full speed. Tighten up this standoff so when I go to remove that screw, the standoff don't spin. Here's the wiring harness that mates the power board to the control board. Okay, get that one side in. Okay, both sides are in. connect to the, there we go. Okay, let's hook up our earth grounds. Okay, now we're going to wait till tomorrow to power this up because the power isn't stable in the shop today. Lights have been going off, coming back on moments later, and I don't want to wig this drive out by losing 460 volts AC and then having it immediately come back on. Might blow that power supply. So, Lord willing and the creek don't rise, we've got tomorrow. Okay. Be careful, folks. Try to stay dry, and we'll see you in the morning. Good morning. Here we are, day 2, and it looks like the power is stabilized in the shop. The lights aren't flickering. Yesterday, we removed the bus bar from bus ground to the emitters of the low side IGBTs, and we removed the current sense board that connects the 3 IGBTs, the C2E1 connections to the terminal board. And hopefully with these 2 things removed, that will allow us to probe around on the firing channels without fear of short-circuiting one of the firing channels and having high side and low side of the IGBTs turn on at the same time and create an explosion. We don't want to do that. But with these parts removed, the DC bus will not be connected to the IGBTs, the power stages. So that's the hope anyways. We're going to power up the drive and make sure that things don't go badly first. Let me get around to the transformer and I'll set these parts down. We'll apply 380 volts AC 3-phase to L1, L2, and L3 of the drive. All right, hold on to your farm animals. Here we go. Well, so far so good. I heard the pre-charge contactor energized and the cooling fans for the heat sink have spun up. Let's go see what's in the display. Okay, get my close-up glasses on, but it's looking good. The drive LED is on. The SEQ LED is on for remote. The display states frequency ref 300 Hertz. I don't have a potentiometer applied to this drive. Now the stop reset LED is on, so we're not running. This drive must be set up just to take off at 300 Hertz. Let's get closer. So let's attach a run forward switch from the S1 terminal to the SC terminal, and drive's turned off. Then we'll see if we can run this drive. There's S1. There's S2. Okay, that's turned off. Now power up the drive. Now with our switch connected to S1 and SC, we're going to see if we can set this drive to run. I was afraid of that. It says alarm PUF DC bus fuse. And that's because I have the ground side, the emitters disconnected, so there's no current flow through that fuse. Well, that shoots down that idea of looking at this firing channels with the drive, or I'm going to have to figure out some other way, or just shotgun that firing channel. Change all the parts in it. I hate doing that though, because I always like to know. Let me get you close to that display and you can see how it came up. Well, plan A failed. So we're going to go to plan B. What I'm going to do is I'm going to tack a red wire onto the collector of this NPN transistor and a black wire onto the collector of this PNP transistor, and that'll power up the output side of the optocoupler. Now, to power up the input side of the optocoupler, let me pull that circuit in and you can look at it. Let me see if I can get this framed properly. Stand up so I can look at the screen. Okay, I think we're in the frame. Here is a secondary of the switching transformer, and when it is running, this diode right here rectifies that AC to DC, and this is the 5 volts for the logic on the control board. It also goes to the emitter of this surface mount transistor right here, Q3, and there's a voltage divider, and the voltage right here on this side of the resistor is set by a Zener diode and this 5 kilo ohm, and that regulates the voltage going to the input side of the optocoupler in the firing channels. So what I'm going to do is I'm going to clip an external power supply ground to these pins right here, the ground pins, and I'm going to clip 5 volts right here. And then we'll be able to power up the input side of that optocoupler. And when I do that, let me bring this page back in. Stand up, make sure we're in the picture. There we are. With everyone powered up, the output side of the optocoupler powered up from an external power supply, I'll be able to, and with this circuit powered up, I'll be able to pull pin 25 to ground, turn on this optocoupler, current will flow through the anode cathode of the optocoupler, and its photons will be emitted into the circuitry that turns output 2 on and off, thus driving into the base of these 2 transistors. And we'll be able to look out here and see if we are switching. Hopefully so. That's plan B. Plan A failed. Maybe plan B will work. As long as I don't hook up something wrong and pop that firing channel circuitry. I hope not. Yeah, sometimes we have to be a little bit dangerous around here. Okay, here we go. Wish us luck. I'm going to turn the camera off while I hook this all up, and I'll turn the camera back on. You don't need to see me soldering on this stuff. You've seen that 1,000 million times. Okay, back in a little bit. So here I've soldered the red wire onto the collector of the NPN transistor, and the black wire to the collector of the PNP transistor. Over here, this is the rectifying diode for the 5-volt logic. I'm going to apply 5 volts to the cathode side of that diode from an external power supply, and then we're going to pick up the logic ground on this connector right here. I have a little pin right there. And if we get everybody successfully powered up, we should be able to drive the input and the output of that optocoupler. And we'll see, we'll look at it with an oscilloscope. But I want to run the U side first, and then the V side, and then we'll do the W side firing channel on the low side IGBTs. We'll see what happens. Okay. Let me get turned around here so I can get in. Here's our 5 volts from an external power supply. Now I'm not sure what voltage to power up this red and black wire, but we're going to put 5 volts on there just to be safe. There's our 5 volts from an external power supply. Here's our logic ground connection on pin 8 of the 7CN connector. Oh, fell out. 2, 4, 6, 8. Then what we'll do, we'll look at the reference to this ground right here. We'll make sure we have 5 volts on VCC of the anode side of the optocouplers here. That's pin 3 on these optocouplers. Okay, let's turn on our 5 volts. Okay, let's see what we got on pin 3. Yes, we have 5 volts on pin 3, the anode side of the input LED on those optocouplers. Now I'm going to turn that supply off and we'll hook up this supply right here. I'm going to turn everybody off, then find me a pin so that I can get on pin 21 of the 7CN connector right here. That's the U low side input optocoupler, cathode side. And then 23 on the 7CN connector right here is the V input to the low side optocoupler, cathode to that LED inside that optocoupler. W, the circuit that I'm concerned about not firing, is on pin 25 of the 7CN connector. So I have everybody hooked up. Now I upped the voltage on the output side of the optocoupler to 16 volts. I was reading the data sheet on that PC929 optocoupler, and it said the minimum voltage for the output side was 15 volts. So I went up to 16 volts. And here on the input side of the optocoupler, I have ground connected to pin 8 of the 7CN connector, and on the rectifying diode for the logic, 5 volts on this side of the optocoupler, and going up to the control board, I have 5 volts attached to the cathode of that rectifying diode. 2 separate power supplies, one over here on the high voltage side and one over here on the low voltage side. So 15 volts over here, 5 volts over here. We're going to get in front of that oscilloscope and see what we get on when we tag the input of the optocoupler by pulling pins 21, 23, and 25 to ground, while looking at the output of the NPN and PNP totem pole transistor that drives into the gate of each low side IGBT. And we'll see if we have one of them not working. And that would explain why we had no low side firing on the W leg. All right, we're going to move the oscilloscope in front of the camera. All right, let's power up the 16-volt power supply and the 5-volt power supply. We're going to look at the output side of the optocoupler on U first. Put my close-up glasses on here. Okay, notice we've gone about 9 volts above ground, which makes me believe that I'm not referencing ground properly, or that black wire is supposed to be a negative voltage and not a positive voltage. Regardless, okay, we're pulling pin 21 of the CN connector to ground. Look at that. We went up to, I can't get on it. Okay, come on. Stop moving around. Okay, we went up to about 16 volts right there. From about 9 to 16 volts. So that output is working based on how we're testing it. Now I'm going to power down and we're going to move to CN or 7CN pin 23. That's going to be the V. And we're going to look at the totem pole of the V circuit. Okay. Lost track of where I was at. 1, 3, 5, 7, 9. 1, 3, 5, 7, 19. 21. 23. I think I'm on 23. 7CN 23. Powering back up. And we're going to put our oscilloscope probe on the emitters of the NPN and PNP transistor. Okay, let's try it again. I'm pulling pin 23 to ground. Okay, that one's working. I need to get a better switch. I'm using a probe, a pick. Okay, there is the totem pole output while I'm pulling 7CN pin 23 to ground. So the V firing channel is working based upon how we're testing it. Pin 23 grounded, pin 23 not grounded. Grounded, not grounded. Okay, now we're going to look at what I believe is the W firing circuit. We're going to move our grounding wire to 7CN pin 25. And that's the cathode to the input LED, the cathode side of the input LED on that W firing circuit. Okay, let me get on the totem pole output of the NPN and PNP transistors. There we go. Looks good so far. I'm grounding pin 25. Oh, I slipped off of the emitters. Let me get back on it. Sorry about that. Stay on there. Alright, we're back on it. I'm grounding pin 25. There we go. Look at that. Grounded, not grounded. Grounded, not grounded. Grounded, not grounded. That optocoupler is not firing into the totem pole output that drives the gate of the low side W. Alright. Well, I'm going to have to order that PNP and NPN transistor and that optocoupler. So it's going to be a little bit before we actually get to test this board again. Okay, good job folks. You verified why we had no low side firing on that W leg. That W IGBT, the low side W IGBT. Let me power down and we're going to get out of here. We got some chores to do at the house. Okay, Now I put my drawings of these circuits that we tested up at the end of the video, and you'll hopefully never have to do this, but if you do, you'll know how to do it. And you'll know what not to do. Okay, y'all have a good day. We'll see you in the next one. Hello, here we are at the house. And because I'm a dummy, I didn't get a video of the actual waveforms of U to V, U to W, and V to W. So I've got a drawing of the representation of what I saw. Now here is a waveform U to V. And we had good low side. This center line right here is 0 volts DC. So if we took our meter, our oscilloscope, and put on U and V terminals, we would see this waveform right here. Low side to high side. Now this should be almost 650 volts DC plus and 650 volts DC minus, centered around ground, and you can see my hash marks for that's our pulse width modulation. So that's U to V. That looked perfect. Now when we get our meter on the U terminal to the W terminal, you can see that we only had the positive side of the waveform. We never went negative here. It should have went negative right here to negative 600 and really close to 650 volts DC. All we saw was the positive side of the waveform from U to W. Again, we went V to W. We put our leads on the V terminal and the W terminal. We saw the same thing, just high side firing. And I'd be afraid to hook a motor up to that because we'd be single phasing for sure. That motor would be jumping around all over the place. But again, with V to W, we had no negative 650 volts waveform down here, nor here, nor here. And the common link between U to V, U to W, V to W was the W firing channel not working correctly, so that we never had low side firing on the W leg. Well, I wished I would have got an actual video, but I didn't. I'm a dummy. But the paper representation is good enough, right? Okay, y'all. I hope that clarified the low side W firing channel not working correctly. Thank y'all for stopping by. I really appreciate it when you come over and see what we're doing next. Stay safe out there, and we'll see you in the next one.